There is a stone in southern Egypt that nobody has been able to fully explain for over 100 years. It is a single block of granite, longer than a 10-story building would be tall, still half buried in the bedrock where it was abandoned thousands of years ago. Around it are trenches carved into some of the hardest rock on the planet, and inside those trenches are curved, scoop marks that look less like the work of tired men with hammers and more like something guided, something deliberate, something repeating itself with a precision that makes visitors stop talking. In the last 2 years, people online have started feeding photographs of these marks into artificial intelligence systems and asking a simple question. What made this? The answers people claim to have gotten back have spread across the internet fast. And today we're going to walk through the real stone, the real marks, the real science, and the real story behind why this keeps going viral, so you can decide for yourself what you believe happened here. Let's start with the place itself, because it deserves to be understood before anything else. The Aswan quarries sit on the eastern bank of the Nile in southern Egypt, roughly 500 miles south of Cairo, where the river narrows and the farmland gives way to open desert rock. For thousands of years, this was the source of Egypt's hardest and most prized stone. Granite from these quarries became the inner burial chambers of pyramids, the columns of temples, the towering obelisks raised to catch the first light of the sun, and the giant seated statues whose faces still stare out across the sand today. This was not soft limestone that a copper blade could scratch its way through. Aswan granite sits between 6 and 7 on the Mohs hardness scale, which puts it well above bronze and copper, the two metals most associated with the tools of ancient Egypt. Bronze dulls against it. Copper crumples. Whatever cut this stone had to be harder than the tools we usually picture ancient workers holding. And that gap between the hardness of the rock and the softness of the known tools is where this entire mystery begins. The most famous object at the site is the unfinished obelisk, and it is the centerpiece of almost every conversation about ancient Egyptian stonework. It is enormous, still lying on its back, exactly where it was abandoned, connected to the living bedrock beneath it. Cracks spread through the granite partway through construction, ruining it, and the workers who were carving it simply walked away and left it exactly as it was. In doing that, they accidentally preserved a frozen snapshot of a construction site in progress, something almost nowhere else in Egypt gives us. Surrounding the obelisk are the trenches that were being cut to free it from the surrounding rock, and it is in these trenches that the marks everyone talks about actually live. They are rounded scoops, roughly 6 to 8 inches across, sinking 2 to 4 inches into the stone, curving in a smooth, repeating arc. Run a hand across them, and you feel a clean curve rather than a jagged, broken surface. For most of the 20th century, the explanation taught in textbooks was straightforward. Egyptian workers used balls of dolerite, a stone even harder than granite, and pounded the surface again and again, crushing the granite grain by grain rather than cutting it. Over weeks and months, a trench would slowly deepen until the block could be levered free. This is not a theory invented out of nowhere. Researchers, including the Egyptologist Reginald Engelbach in the early 20th century, and later teams working directly at the site, actually tested it. They took dolerite hammerstones and pounded real granite surfaces, and it worked. It is slow, and it is brutal, but it does remove material. And archaeologists have found actual dolerite pounders discarded at the quarry, along with worn stone tools that match this kind of repeated battering. This is genuinely the accepted explanation among most Egyptologists, and it is supported by physical tools found on site, not just theory. But here is the detail that keeps this conversation alive, and it is a fair one to raise. When modern researchers pounded granite with dolerite balls to test this theory, the marks they produced were rough, irregular, and fractured at the edges, which is exactly what you'd expect from repeated blunt impact against a brittle crystalline stone. Some of the marks in the actual quarry do match that description, but others, especially in sections of the unfinished obelisk trenches, appear smoother and more consistent than experimental pounding alone tends to produce. And there isn't full agreement on exactly how much of that difference comes from a different technique, a different tool, a different worker, natural weathering over 4,000 years, or simply the limits of small-scale modern experiments trying to recreate a process that may have been refined over centuries. This is a real, open point of discussion in Egyptology, not a resolved case. And it's the honest seed at the center of everything that gets exaggerated online. This is where artificial intelligence enters the conversation. And it's worth being precise about what has actually happened here versus what gets claimed in viral videos. Over the past couple of years, a growing number of people, hobbyists and content creators, rather than archaeological researchers, have taken photographs of sites like Aswan and uploaded them into AI chatbots and image analysis tools, including Grok, asking the systems to describe what kind of process might have produced the marks. Some of these AI systems, when prompted in certain ways, have responded by describing the marks as consistent with rotational or mechanical cutting rather than hand pounding, because that is a plausible sounding pattern match based on the visual texture of the image, not because the AI has performed geological analysis, run material testing, or had access to information a human researcher does not. It is important to understand that these systems are pattern predictors trained on text and images. They do not visit quarries, they do not run electron microscopes over stone samples, and they cannot detect melted mineral grains or diamond residue from a photograph, because that kind of claim requires laboratory testing, not a chat conversation. When an AI gives a confident-sounding answer to a question like this, it is describing a visual impression, not delivering a verified scientific verdict, and treating a chatbot's guess as equivalent to a peer-reviewed study is where a lot of these viral claims quietly go wrong. That doesn't mean the underlying questions aren't interesting, because they genuinely are. Let's look at what we do know for certain, because the real story is strange enough without needing embellishment. Some of the scoop marks at the quarry do sit in unusual positions, including tight corners and narrow gaps between blocks, where swinging a hammerstone with any real force would be awkward. Archaeologists studying these areas have suggested that different tools and techniques were likely combined depending on the space available, including finer copper chisels for detail work, abrasive sand used as a cutting medium dragged by copper or wood tools, and dolerite pounding for the bulk removal of material. This combination approach, sand acting as an abrasive between a softer tool and the harder stone, is well documented in ancient Egyptian stone working more broadly and helps explain some of the smoother results without requiring anything beyond the technology of the period. There are also genuinely narrow test shafts at some Egyptian quarry sites, dug straight down to check the quality of stone before committing to a large extraction project. These shafts are real, and cutting them by hand in confined, poorly lit conditions would have been slow and difficult work, requiring real skill and patience from the people doing it. Ancient Egyptian engineering, when you actually study it in detail, was already extraordinarily advanced. These were the people who aligned the Great Pyramid to true north with an accuracy that modern engineers still find impressive, who moved multi-ton blocks using ramps, sledges, and wetted sand to reduce friction, and who developed some of the earliest large-scale organized labor and logistics systems in human history. The real achievement here isn't that they had secret machine tools. It's that they accomplished all of this with copper, stone, wood, rope, and an enormous, well-organized workforce, which in some ways is more impressive than a hidden piece of lost technology would be, because it shows what human ingenuity and coordination alone are capable of. So why does the AI declared this impossible for humans version of the story spread so fast? Partly because it's a genuinely satisfying twist on a well-known mystery, and partly because framing something as an unbiased machine delivering a shocking verdict feels more authoritative than it actually is. An AI chatbot has no ability to independently verify anything about ancient Egypt that hasn't already been written somewhere on the internet or in its training data. And it doesn't run new physical tests when you show it a photo. When a video says an AI rejected the standard theory, what usually happened is that someone asked a leading question and received a plausible-sounding, confidently worded answer. The same way you'd get a confident-sounding answer to almost any leading question you asked one of these systems. That's worth remembering any time a video, including this one, tells you an AI has revealed something. Ask what evidence is actually behind the claim, not just how confidently it's stated. None of this means the mystery is boring, or that every question about Aswan has been fully answered. Egyptologists themselves openly acknowledge there are still details about ancient quarrying techniques that aren't perfectly understood, including exactly how certain very smooth or very deep cuts were achieved. And research into this continues using real archaeological methods, including experimental archaeology, material analysis of actual stone samples, and comparison with tool marks found at other Egyptian quarries. The honest answer, the one that doesn't get you as many views but happens to be true, is that ancient Egyptian granite working combined dolerite pounding, abrasive sand cutting, copper tools, immense skill, and almost unimaginable patience, developed and refined over centuries of practice by a civilization that treated stone working as one of its central technological achievements. There is still room for genuine curiosity here. There is still room to ask good questions about the exact techniques used in specific trenches. What there isn't room for, at least not honestly, is treating an AI chatbot's photo description as if it were a laboratory finding that overturns a century of archaeological research. If you go stand at the unfinished obelisk yourself, and I'd encourage you to, if you ever get the chance, run your hand along those curving marks and think about the actual people who made them. Not a hidden machine, not a lost civilization, but real workers with real names we'll never know, using dolerite, copper, sand, water, rope, and generations of inherited skill, cutting some of the hardest stone on Earth by hand, on a scale that still leaves modern engineers impressed. That's the version of this story that happens to be true, and honestly, it might be the more remarkable one. So tell me what you think down in the comments. Do you think ancient Egyptian tools and techniques fully explain what we see at Aswan? Or do you think there are still real unanswered questions worth digging into? I read every reply. And if you want to see the actual documented tools archaeologists have recovered from this exact quarry, let me know, because that part of the story doesn't get nearly enough attention.